Rain helps the ocean trap more carbon, according to a new study. Rain has so far been ignored in calculations of the ocean's capacity to take up carbon, but a new estimate shows it enhances the ocean sink by 5 to 7%. 3 decades ago, David Ho set up 2 pink dinosaur-patterned children's pools in the parking lot of a NOAA building in Miami, where afternoon thunderstorms were common. He was 22, freshly done with his undergraduate studies and working as a technician at NOAA. He filled both pools with water, added a gas tracer, and put a canopy over one pool as a control. Then every day for several months he waited for the downpour, getting drenched as he pulled up samples from each pool in glass syringes. He said, "It was pretty miserable, but I got some interesting results." These early experiments showed that the rain enhanced the transfer velocity of carbon dioxide, CO2, or the efficiency with which it's transferred from air to water. Ho, now an oceanographer at the University of Hawaii at Manoa, has pursued the research topic ever since, scrutinizing the effect at a NASA rain simulator and during research voyages in the Pacific. His latest study is the culmination of this work, delivering the first comprehensive and global estimate of what happens to CO2 fluxes when rain hits the ocean. The global ocean takes up about a quarter of the CO2 emissions from human activities, and this research shows that rainfall raises this uptake by 140 to 190 million metric tons, or 5 to 7% per year. It might be surprising that this should take so long to quantify this process, but partly it's because this is a hard problem to examine, Ho said. Most measurements of gas concentrations in the ocean come from ships, which collect water samples at a depth of 5 to 7 meters. But because rain hits the surface, its effects are invisible at those depths. This has been ignored because we don't have the data. Turbulence, dilution, and wet deposition. Carbon dioxide uptake in the ocean is not uniform. Some regions act as sinks, drawing the gas down, while other areas release it. When a raindrop falls into the ocean, it temporarily changes the physics and chemistry of the seawater around it. The study identified 3 main means by which rain increases the ocean's carbon uptake: turbulence, dilution, and wet deposition. When a drop strikes the surface, it generates turbulence that brings more water in contact with the atmosphere and the carbon it contains. Each drop is also a splash of relatively fresh water, which dilutes the seawater and changes the air-sea concentration gradient of CO2, enabling higher uptake. And finally, wet deposition refers to how each drop absorbs CO2 as it falls through the atmosphere, then injects that gas directly into the ocean. Wet deposition is a one-way flux, said Rick Wannenkopf, an oceanographer at NOAA, who pioneered the use of inert chemical tracers to study gas exchanges between air and water. Wannenkopf was not involved in the latest study, but worked with Ho on the pool experiments. We did not think about this in early studies, but on the global scale, this research shows that this is probably one of the single largest effects of rain on carbon dioxide fluxes, he said. The study was led by Laetitia Park as part of her doctoral studies at Sorbonne University in France. For her, the most significant finding is that the size of this rain effect on ocean carbon uptake is comparable to the size of the global carbon budget in balance, or the estimated difference between total carbon emissions and total carbon absorption by the ocean and land. Being able to quantify these small-scale processes at the air-sea interface should improve scientists' ability to model carbon flows between the atmosphere and the ocean, she said. Tracking rain patterns across the ocean. A pivotal part of the research is a model developed by co-author Hugo Bellinger that tracks rain-induced salinity changes at the ocean surface. Physical models for the ocean skin were first developed in the 1960s, said Bellinger, a climate modeler at the Laboratoire de Météorologie Dynamique at the French National Centre for Scientific Research, CNRS. But while they tracked temperature changes well, there was previously no measurement of the salinity counterpart. This model allowed the researchers to delineate where rain has the strongest impact. Turbulence and dilution play prominent roles in the tropics, which are characterized by very heavy rains and weak winds. The effects of wet deposition are also significant in tropical regions as well as in other areas with heavy precipitation such as storm tracks and the Southern Ocean. So this came as a surprise. Park said we were expecting the rain to mainly increase carbon uptake in the tropics, to find that it could also have a noticeable impact in regions of higher latitudes was unexpected, Park said. Tatiana Ilyina, an earth scientist, carbon cycle modeler at the Universität Hamburg in Germany, who was not involved in this, said the study quantified an effect that so far has not been considered in observational or model-based estimates of the global carbon budget. It sends a strong signal we have no excuse not to consider these effects in our global carbon budget estimates. The effect could grow stronger as the world warms and precipitation increases. The team found that wet deposition rates scale with the rate of rainfall. Storms are already dumping more rain, and scientists expect precipitation patterns over the ocean to shift with climate change. In their analyses, based on satellite observation and reanalysis of global weather datasets from 2008 to 2018, the researchers saw a slight growing trend in the effect of rain has on the ocean's carbon uptake. And the work brings attention to yet another previously unconsidered carbon-climate feedback, Ilyina said. Getting precipitation patterns right has been a long-standing issue in global models, and now we know that this has direct implications for quantifying the ocean carbon sink. And this was published on eos.org. This is by Veronica Meduna on Life Science. My question is, does this have a common partner with rain on land? Not an ocean, but on land as well. Does the rain on land also have a carbon capture? Please leave your comments, and thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.